Hello everybody and welcome back to more of the 2005 Euclid contest. We're up to question number 3 in this video. It's got a light bulb and a written part, so let's tackle question A, the light bulb first. If 2 to the x is equal to twice 16 to the 12 plus twice 8 to the 16, what is the value of x? So we just need our final answer here, but we're going to show our work, just in case we happen to mess up a little bit. So one of the nice things about powers that if you're not already aware of, you should become aware of, is if you have something to the effect of 2 to the a is equal to 2 to the b, then you have to have a is equal to b. Same base, same exponent if there's an equal sign, that sort of thing. Okay? So that's what we're going to exploit for this one. So we have 2 to the x. What we want to do is change the expression that they gave us so that it is just it's just 2 to the something. And we can tell that this is the approach we want to take because we've got 2's and powers of 2 everywhere. If we saw a 3 in the base, then maybe we'd have to consider a different approach. But we got 2's and powers of 2 everywhere. We're all set. So the first thing I'm going to do is I'm going to change my 16 into 2 to the 4. And my 8 into 2 to the 3. Before I go any further, I do want to double check. It was 16 to the 12, right? 16 to the 12, 8 to the 16. Okay, we're good. All right, so now, using the properties of exponents, if I have something, or a to the b, and then all of that raised to the power c, that's the same as a to the b times c. So we've got 2 to the 4 times 12, so that's to the 48. Plus 2 to the 3 times 16, which is again 48. Now each of these 2's out front is really 2 to the 1, and when we multiply powers of the same base, you are allowed to just add. So we get 1 plus 48 on top, 1 plus 48, so 49's for both of these exponents, but this is the same number repeated, so we have 2 copies of it. And again, that 2 is just 2 to the 1, so we have 2 to the 50. So x is 50. Okay, because we argued it down to a point where we had 2 to the something. All right. So that was A part. We did just need 50, but we've shown our calculations just in case. All right, B. If f of x is 2x minus 1, determine all real values of x such that f of x squared minus 3f of x is equal to, or plus 2 is equal to 0. Okay. So, what do we want to do there? So I can think of sort of 2 ways that we might want to do this one. Okay. So, one way we might want to handle this is to say, okay, I'm going to replace f of x with just a variable, say something like y. Okay? And then I can change that second equation into one that is solely in terms of y. So y squared minus 3y plus 2. Solve for that, solve for the y's, and then say, okay, y has to be equal to 2x minus 1, then solve for the x's. Alternatively, what we could do, and this is sort of another way to do it, is we could take that 2x minus 1 and sub it into the equation. Okay? And if we were to then sub it into the equation, we'd be able to expand it, 2x minus 1 squared minus 3 times 2x minus 1 plus 2, and then we'd get a single equation. It'd be a single quadratic in terms of x, and we could solve it that way. Both of them are perfectly fine. I think I'm going to go with my first method just for clarity's sake. But I admit probably when I did this one, I just took the 2x minus 1 and subbed it in. Okay, and that's perfectly fine too. I just think that's going to be slightly messier. ever so slightly. Okay, so let's take a look here. We have to write down what we're doing, so we'll say, let y equals 2x minus 1. Then f of x all squared minus 3f of x plus 2 is the same as y squared minus 3y plus 2. First, let's solve for y. So y squared minus 3y plus 2 is equal to 0. Well, this, if it's written like this, is quite quick to factor, actually. We need two numbers that multiply to 2 and add to negative 3. I'm going to go with y minus 2 and y minus 1. So y is equal to 1 or 2. So now let's solve for x. So 2x minus 1 is equal to y is equal to 1 or 2. So then 2x is equal, we'll bring the 1 over. So 2x is equal to either 2 or 3. Divide by 2, x is either equal to 1 or 3 halves. And we could probably put a box around that. Okay. And I'd say that's a little quicker, it flows a little nicer, rather than plugging in the 2x minus 1 and expanding it all out. Okay. Perfectly fine. Little things can help us optimize. And so instead of plugging in, introduce a new variable and solve for that. Because you'll notice y squared minus 3y plus 2, very quick to factor that. Whereas if we put the 2x minus 1 in there, we'd be looking at least a 4x squared would be somewhere. I don't know about you, but I find the ones where the coefficient of the x squared is 1 a lot easier to factor. Okay, so I try to avoid the other style of situation. But we could certainly, some things might have been able to divide by 4 or something like that. As a matter of fact, I've done the question, but I think I'm going to actually gauge how much harder it was to actually do the 2x minus 1. This is also a little double check for me, having just done the question, to say, well, is it really 1 and 3 halves? Okay, but I'd say this is a perfectly fine, very quick method, and if you want to end the video here and move on, but I'm just going to compare the two methods, the subbing and the 2x minus 1 here. So we'll get a scrap piece of paper, and we'll do 2x minus 1, because that's f of x, squared, minus 3, 2x minus 1, plus 2. We say that's equal to 0, so we'll have 4x squared minus 4x plus 1 minus 6x plus 3, all plus 2 is equal to 0, so we'll have 4x squared minus 10x plus 1 plus 2 plus 3 is 6. So we can divide by 2 here. But it is not entirely obvious how to factor this. Okay. Now, one thing that's nice to note, the coefficients, if you add them up, equal 0. That does tell you that 1 is going to be a factor here, but it's not entirely obvious. Okay, so you would have to either quadratic formula, which would be perfectly fine. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2 times a, which is 4. So you get 5 plus or minus 1 over 4. Which is 6 over 4, or 4 over 4, which is 3 halves, or 1, which is what we originally predicted. Or if you made this observation that 2 minus 5 plus 3 does equal to 0, so x equals 1 is a solution. You could factor out the x minus 1. So what do we have? In order to make plus 3, we would need minus 1 times something to be plus 3, so that's got to be minus 3. And then what do we need? Well, in order to make 2x squared, multiplying something by x, it would have to be 2x, and you could double check negative 1 times 2x is negative 2x, minus 3x does give you the minus 5, and so from there x equals 1 and x equals 3 halves. But I would say that definitely this was the longer way to do it. Okay, not appreciably longer, and certainly if you're quite comfortable expanding, if you're quite comfortable with the quadratic formula, you probably wouldn't have noticed any difference either way, but I would say the first method was a little clearer, and that's something we want to be aware of because we want to go quickly. We want to go quickly, especially, it's question 3. We want to save as much time as possible for the 8, 9, 10, the harder questions. Or, if this is your first year, maybe save time for the 5, 6, 7, which might be the hard questions for you because you'll say, no, there's no way I'm doing 8, that sort of thing. Okay? But that's it. That's question number 3. In the next video, we'll take question number 4. Thanks for watching, and as always, I'll see you guys next time.